Today we will talk about functional testing overview. I guess that's as Winifred you mentioned, that's more about a kind of a kickoff. We will give a brief overview of what we are doing, and definitely would be ready to go deeper into details, but probably not during this meeting. But schedule another one or a few of them, and get more technical experts from our side as well. To go deeper and to discuss where maybe the use cases for us, where we can find common points. I will talk a little bit about our current scope of work, so in which direction we are working, and in particular related to robotic drive simulation ecosystem and a few use cases from there. And also, we have a couple of slides related to infrastructure-based driving solution, which also seems to be quite interesting in this discussion. So let's move forward and a very brief introduction into how do we see the whole process of functional testing and validation, and what actually we offer to our clients is an end-to-end story. I guess what is missing here is the data collection right now, which became also a part of our offering for clients, and all other blocks and of the pipeline of functional testing validation, which is essential part of AD development. We actually would like to offer to our clients, which starts with data collection and also analysis of the data in the vehicle, storage this data, ingestion, structure of the data, which allows to do read of different data formats, getting access to this data. And that became a challenge when we start talking about data-driven development, which is a modern part of new level 3, level 4, and level 5 autonomous development. And what we're facing with our major clients who operates with petabytes of data. Data-driven development started with 100 petabytes of data, and therefore structuring the data and getting access and get distributed access to the data became a real challenge that we actually help to solve to our clients. We also have offering in labeling data and preparation of the ground truths and verification of the algorithms and final deployment into the vehicle. If we go a little bit into the details, what we see as a part of functional testing problem, let's say, I guess that major points for us, together with obvious things like what we do is in proven ground and open road tests, when we do sensor recording and, as I mentioned, the ground truth, the labeling. The major part seems to be for us is how accurate we are in our models, in simulation tools, in other things like virtualized ECUs, and how scalable our solution is. So since I mentioned the challenge that we are facing with a petabyte scale, with millions of miles collected of the data from one hand, and another requirements which came from more about simulation part, which shall cover like billions of miles. All the solutions needs to be really scalable and support this demand on amount of data. And here we go a little bit more deeper into functional testing and validation components. So we see that in our ecosystem, we need to connect multiple things related to, first of all, environment models like maps, roads, or traffic, or weather conditions, etc. From one hand, from another hand, this is the vehicle models, sensors models. This is also what I mentioned as a virtualized ECU. This is the other thing that we also working on, which includes testing of the ECU without the real ECU, right? So The idea is to move to a virtual world even more and simulate, let's say, the vehicle compute units inside together with operational systems like AutoSAR inside, together with probably integration of these ECUs in one bus, and for example, Ethernet simulation as well also might be part of this work. Right, and we also considering the working with the test cases, scenario libraries. However, to add into this picture, right? So we see to the common standards or general requirements which came from regulations, and to support that, definitely we need to have some traceability between test cases and the requirements. So therefore, I mentioned it here as quite important part. And at the end, when we do the modeling, when we do the simulation, we also looking for some solutions which will allow us to build and calculate KPIs and also do the analysis of that. So all of that is required actually for from one hand statistical validation and from another one the system validation steps to support sign off and homologation process, which is like, you know, very brief idea of what I mean saying statistical and system validation is that we need to prove statistically that the function or the car itself, the whole vehicle is safe enough, or the particular function is good enough. And for that purpose, there are some obvious KPI analysis or scenario validation variation that we use. But from the other hand, we also need to show and to understand that we can trust the statistical validation results. So therefore, such things like as a simulation itself, validation and test case traceability is quite important. Just, you know, just to demonstrate the idea, I added here. That's a funny video, but you know, even if you get the cool KPIs which says that your vehicle is safe enough, how can you trust the tools that you're working on and make sure that what you're testing is not look like, you know, like this one? So that's a very brief idea, very brief introduction. So I guess that's we shouldn't spend a lot of time on that. What is more interesting is to show in which directions we are actually working right now. We have three so let's say streams. First one is a building ecosystem around robotic drive solution, which is a data platform, is a platform for AD development, and where we definitely need to have functionality for functional testing and validation and simulation phase. Another one is where we have connection points is simulation COC, and we will talk a little bit about that. So today it's infrastructure-based driving. And final one, where we also touch with the simulation, is how we approach the ground truth generation. We have a special program which we call highly automated data automation annotation. Sorry, where we also use the simulation capabilities for testing of our models, for training of models, and finally to improve the ground truth generation. So right here we see that how we use the LG SVL component for robotic drive system. It's just you know, just a component, just a black box for us in general, and mostly we are focused on something which are let's say simulation tool agnostic, but helps to integrate the simulation into the platform itself. So like creation of a flexible cloud-based environment for that, or execute on a highly scalable way. For the infrastructure-based driving algorithms development, we are going deeper into the simulation part and make it as a part of our CI/CD process as well. Do training similar as to ground truth generation, and also do validation of our algorithms with help of the simulator itself. Let's then move forward, and we'll tell you briefly about the ecosystem in general that we are building on the robotic drive part. As I already mentioned, that's let's say the full pipeline of AD development step, starting with the collection, data ingestion, and storage. Again, that's became a real challenge when we start talking about huge data sets like petabytes or hundreds of petabytes of data. And what is our pipeline to came to the road approval? So finally developed and signed off AD functions. We need to do the analysis and management of the data, do testing and help to develop algorithms like perception, location, localization, etc. And as you see, the simulation also part of this pipeline. And we're actually building this ecosystem for the developers, right? So who is doing the development of AD functions? From one hand, from other hand, this is people who is doing a testing and validation of AD functions. So all of that, we see that it's quite critical to make all components accessible to our clients. And our clients are, hundreds of engineers on a client side, or even thousands of engineers on the client side, who would like to access all these capabilities, like compute capabilities, simulation capabilities, and data itself. Very high level and very briefly idea of how we see this on a high level architecture. I guess that's not a lot of insights here, but we can go deeper into these details later deep dives. I just would like to mention that as I said previously, we also focused on sensors and KPIs capabilities, which are kind of pluggable system for the simulation tool. And also working on the kind of a cloudization. So therefore, it would be really interesting to see what LG Premium simulator can offer in this area. Just to give a brief overview, if of course, yes, that's how do we see the testing process. Which helps us to that's a very simple demo, but in general, which helps us to select some scenarios, select the KPIs that we want to calculate, and how we want to alternate these scenarios. And yeah, I guess that's this pretty well the simulator, right? So what is, let's say, also critical for us, that running the simulation in a highly parallel mode, when we can test loads of scenarios, loads of alternations. And finally, to get into the test results, so how good we were in test, and go deeper into each particular test and see how good we are in a particular KPIs that we would like to calculate there. Another thing that we also are working on and focused is the sensor models. And here and in the driving simulation, we also have a little bit more about that. So the idea is to build our own models, and which are closer to physical world works, and also has some limitations or requirements, like to be flexible or to work in a real-time mode. From one hand, but from the other hand, allow us to do more realistic sensors. I guess that would be better to see a little bit as an example. Right, so that's the sensor. The bottom one is a sensor that was implemented. So I think it's not easy to see, but there is some noise which is closer to.
We see the one who knows where to look. They see.
Yeah. Okay, good, good. Right now we are in the process of validation of this model, and to do that, we actually try to address with some specific ideas, like how our models, perception models trained on the real data, how good they are on the real sensor, I'd say the more realistic sensor and less realistic sensors.
Actually, the picture on the top with a LiDAR, which you said this is not really precise. I believe this is old version of a simulator. I can see this line, like it is as a line segments. So latest version as that's fixed.
Yeah, thank you, Dmitry, for this comment. That's right. We started doing that, I guess, in September. So that's probably a version of a September or some.
Yeah, most probably.
Right, and just a few other things that we are also thinking on and considering. Probably won't have a lot of time to talk about them today, but this is the the demand that we see from few of our clients, and in general in automotive industry. This is a standardization of the models for exchange. And we try to think how we can fit into functional model, functional mockup interfaces as well. So this is, as we understand, any standard will allow to share these models and to build more efficient pipelines from them. And another thing is what is also quite important, as the more generic thing where we trying to think how we can fit with the simulation models is another standard overview, like how we work with the standards of sensors, how we work with the standard of traceability, and how to connect co-simulation with hill stations. So that's a few other topics that we also researching or working with. And I guess we also have a few more slides related to infrastructure-based driving solution, and I would like Philip to briefly tell about that. Philip, can you hear me?
Yep. Thank you, Sergey.
Yeah, just tell me when I need to switch to another slide.
Okay, perfect. All right. So infrastructure-based driving. What infrastructure-based mean in context of this solution? So it means that we have minimal requirements for the car, that there is no sensors or intelligence embedded within the vehicle. The only requirement is to have a network connection. So this solution can be used with vehicles we have or will have soon. All functions here are realized in the cloud, or optionally on some edge computer. That is orchestrating multiple vehicles, motion planning functions, perception, fail-safe mechanism, including teleoperation mode in case there is a failure or system misbehaves in some way. So the car itself must be able just to execute simple trajectories, like one is equipped with parking assistance systems. And so what would be use case for such a solution where the car is driven with external sensors and with sensors being built in the infrastructure? so mounted externally in observing car. So if you, Sergey, could switch to the next slide.
Yep.
Thank you. So we could think about a few use cases here. First one, that's the one we started with, is industrial automation. So you could imagine automating last step of the manufacturing, like when the car basically leaves the manufacturing line and has to be parked somewhere to wait for its turn to be transported anywhere. This is usually done by a human driver, but we can automate it with no requirements on the car being manufactured, just with sensors mounted in the factory, so in strictly environment. From there, I mean, next, yeah, sorry. Next cases would be, you could stay on the last one, doesn't matter. Thanks. So next cases would be automated logistics centers or car rentals, etc., and automated valet parking, which is end customer targeted, let's say. So imagine leaving car at the entrance of the parking garage and just summoning up when you're done. And last but not least is the ground proving. So that this use case would be useful for validating your functionality that you tested in simulation, or trained your algorithm or tested it in simulation, and then you want to see how does it perform in the real world. So you have to set up exactly the same scenario in real world with other cars, and there the infrastructure-based driving solution would allow to precisely place different cars in places where they should be, and perform some trajectories and observe how your car under test performs, how the function performs. So now next slide, please. Okay, so this is the solution architecture overview. I mean, here are put most of functions that we that I was mentioning already. You can see that most of them are that all of them are actually performed in the cloud, not in the car. Only the only part on the vehicle side, let's say, it's the actuation system. But what is most important from simulation perspective is on the next slide. So here is it's easier to visualize what we actually would like to simulate within the infrastructure-based driving solution. So so far we are heavy testing on ground with real equipment. It's, well, not that easy. So we thought about having a digital twin of the whole environment, meaning any parking garage, etc., or the factory, with sensors exactly as we used in real world, and vehicle as we have to control it. So and next slide, please. Okay, thank you. First problem that we actually encountered when trying to simulate this was that there is no AD focused simulator that would offer you ability to have external sensors out of the box, let's say. So that was the first problem we faced, and we simply decided to try to do it on our own with LG Simulator. I think we even had some email exchange with Dimitri in this matter.
Yep.
Yeah, that was a while ago. Anyway, so we came up with such an architecture, let's say, for simulating the whole solution with LGSVL. That is, most of it is, or almost all of it is containerized, so we can deploy it on in the same setup on cloud, on edge computer, on some VM just for simulation purposes. And our system is not ROS based, not yeah. So we had we have those adapters, and we have a couple of modifications on the simulator itself. We maintain our own fork that we bring this possibility to have external sensors plus some custom sensor models. I will tell a bit more details about it later. Also optimize the bridge and a couple of other functions. And the main use cases that we identified for the simulator in our solution was first one was very simple to evaluate sensor setup. That is like, where should we place sensors to get best field of view coverage with minimum amount of sensors? Speaking about LiDARs here specifically. Others are pretty standard. I mean, synthetic data generation for training detectors. Also evaluating KPIs for multi-object tracking, which is essential part of the solution. The path generation, movement safety. Many of our functions are parameterized with many parameters. So the hyperparameters. Imagine you run a simulation number of times to select the parameter selection that gives you best results. And last two are continuous development integration pipeline, just for verifying whether new functionality doesn't break the whole system, and operational short horizon simulation that I'll also tell a bit more later. Next slide, please. So this one is just to give you like overview of how we evaluate sensor setup. This one is with this Velodyne-like LiDAR from default implementation, let's say. We can play around with setting up in different heights and different tilt angles to see what is the coverage, basically. However, the Velodyne, it's not the sensor we use due to its price tag. So if we can switch to the next one. This one is showing how we developed a sensor model for a LiDAR that has non-trivial scanning trajectory, and that was kind of the challenge. It's very different.
That's amazing.
Thank you. Yeah, that's very different from Velodyne's, and as we have real devices with us, we could basically play around and identify its characteristic, and then basically implement it within the simulator. So you can see how the point clouds are looking in RVs, for instance, and simulate. Next one, please. So when speaking about sensors, the problem we also faced was performance one. In our solution, we use many sensors. That is at least 5 LiDARs plus some cameras, and this is huge amount of data being sent with high frequency. And we soon realized that there is a problem with this default bridge implementation, ROS bridge implementation from the simulator. We couldn't get with our sensor setup. We couldn't get anything more than 2 hertz, which was below our minimum 10 hertz requirement. So what we simply did, we implement our own bridge with with faster sterilization methods, etc., and could get this 10 hertz minimum 10 hertz frequency of all sensory data coming to our algorithm.
Yeah, that's very interesting result. And the bridge you're using, is it the custom bridge? Like it's a custom bridge.
Right now, yes, it's the custom bridge. So it's not ROS based anymore. However, we can have ROS adapters on its running market. So you would get all data translated to ROS. But yeah, I mean, there is no WebSocket communication between the bridge and the simulator now.
Yeah, we're actually working on the plugins for the bridges. So if you just follow the same pattern what we have right now, most probably it should be very easy to convert it into plugin.
Okay, yeah, that would be interesting. Definitely. Okay, if there are no more questions, we can go to the next one. Yes, and the last use case I mentioned before was this short horizon simulation. So this is kind of what we are experimenting and researching on right now. Let's say there is an operator near the area which is where the infrastructure-based driving solution is used, and the operator usually sets some mission, so the car executes executed. And imagine that the operator would like to like pre-simulate in short time horizon how the car would drive, what would be the trajectory, and whether the mission can be executed safely. So here we could use the simulator as a part of the solution that is available also to the end operator. Let's see. So having the simulator plus some of data being real data from sensors, actual data from sensors, simulate this next closest actions and see whether solution is plausible, and if it is, then okay, execute the mission. As I said, it's something that we are actually researching on, because I mean we already have whole solution integrated with the simulator. We can simulate all needed scenarios within it. Now we are like trying to scale it to more machines, and also play with such cases. That would be it for the infra drive solution. If you have any questions.
Great. Thank you, Philip.
Thank you.
So I guess that was a very brief overview of what we're doing, with a little bit deeper dive into infrastructure-based driving. And as I mentioned, if we will find out that would need to tell more about the things, so we can do probably this on the last part of our session today.
Okay.
We are ready to share more information on these things.
Oh, thank you, Sergey. This is a wonderful information that you share. Let's see if we can return the favor, show you our next generation simulator. With that, Brian, let me give you the presentation ball.
Yeah, hello. Let me share my screen.